These, okay. You want to verbalize these? Generally, these can be verbalized pretty easily.
Yeah. Oh, sorry. Do you have the meeting ID number?
Oh, sorry. It's 785-916-541.
Okay. Okay. Sorry, my page got weirded up. Connecting. Okay. So, the first one says it's expanding.
Okay.
And it says the log of base 6 is 3x, or 6. I don't know how to verbalize these. Base 6 and then 3x? Okay.
Yeah, that's what I usually say, is log base 6 of 3x.
Yeah, okay. Yeah. And then it wants to expand it.
Just that?
Mm-hmm.
Okay.
That's it for this one.
Okay, so when you have the log of a product, what is it equal to?
It's the same, so it's equal to the log of base b of u plus the log base b of b. All right, whatever.
So that's it. Yeah. Now, this, of course, is a number. But that's the only expansion we can do.
All right. So, here's one. Going to the x one is kind of tricking me up. Okay. So, it says log of x squared over 4.
Okay. Let's do it one step at a time. Let's treat the division part first. Let's see. This is like this, right?
The x squared over 4. I don't know if my computer's being slow.
Yeah, that's the way I've written. Yeah, okay. So let's do the division part first. So what
it's not letting me see your screen, I don't think.
Oh, really? It says you're offline.
Oh?
Yeah. You're hearing me because we're on a different connection for the audio.
Yeah.
Might try logging off and logging back in. What does your GoToMeeting panel say right now? What's it indicating?
Well, it said that there was an issue with audio, but it hasn't indicated any connection problem. Oh yeah, the connection's been lost.
Yeah.
It does now.
And does it give you an option to reconnect, or does it force you to kind of do it on your own?
It just says, yeah, do it on your own. There's no...
Okay, well go ahead and X out of the GoToMeeting and restart it, and I'll give you the meeting ID number again.
Alright, I think it's my Wi-Fi. I think it's not going to cooperate. Awesome. Okay. Sorry.
You have the telephone checkboxed, right?
Yeah.
Okay. Because I actually have mic and speakers, it's the only way I can record the session is if I checkbox my mic and speakers. I don't think that would matter in terms of your connection with me. I don't know.
Have we done it before?
Yeah. No, it took me a couple of times to figure out that the only way I could record audio is if I set it up like this. So I've been doing it this way the last 2 or 3 times.
Alright, well it seems like before. It's just being really slow.
Yeah.
Things working.
Have you, you've logged off and trying to log back on?
trying to verify communications.
It's almost like you lost your internet, maybe?
Yeah, I'm getting the little death triangle on my internet thing.
Why don't you reboot your computer?
Yeah, that's what we're trying to do.
And then you and I can talk about this log problem while we're doing that.
All right.
Do you have a piece of paper?
Yep.
And pencil?
Yep.
All right. While your computer's rebooting, the log of x squared over 4. Let's separate that into two stages. How do we separate the division part of it?
So, sorry, it's weird because I can't see. Oh, I was asking for the meeting ID now. My internet's back.
It's 785.
785, yep.
916 541.
Okay. All right. So, logs. All right. So for that, would you want to multiply? Wait. So the division property are the quotient property?
Well, when you are dividing, it's the same as subtracting. So the log of this becomes the log of x squared minus the log of 4. In other words, division becomes subtraction.
All right.
Now we can further expand that. What's that equal to?
Would it be equal to log x?
No, you can always bring the exponent and put it in front.
Yeah.
And that's a really important property of logs. Remember that, because in all higher math, that's a huge ability to be able to get that exponent down on the line. So that's fully expanded. And then, of course, the log of 4 is some number. Well, it just said oh, okay. You seeing everything now? Fine?
Yeah.
Okay, good. All right.
All right. So condensing expressions.
Okay.
Is what I have to do.
Mm-hmm.
So one of them says, let's get the easy one. So 2 log base 5 of x plus log base 5 of 3.
And notice you can't do anything with condensing or expanding unless you have same base. In other words, if this was log base 7, I would not be able to do anything with this. But since they're both log base 5, what's the first step? What can I do with this 2 over here?
You can make that into an exponent.
Uh-huh. Like that.
Yeah.
And now handle the addition. What does that become?
Log, or 2 log base 5.
No, not 2 log, because we've already moved the 2 to the exponent.
So then just log?
Just log base 5 of what?
3x squared?
Uh-huh. And that's really all there is to expanding and condensing, is using the 3 log rules. In other words, these 3 log rules. The log of a times b equals the log of a plus the log of b. The log of a divided by b equals the log of a minus the log of b. And the log of a raised to the b power is b times the log of a. 1, 2, 3. Being able to go backwards and forwards. Going to the right is expanding, going to the left is condensing.
Okay. Here. I usually put the hardest ones last. I'll just put the last one.
Okay, good.
So it says log base 3 of 4 plus 2 log base 3 of x, or minus log base 3 of 5.
Okay. What's that going to be equal to?
Okay.
I like to follow a set pattern when I do these. In other words, I always do this one as my first step. Let's get rid of the coefficient in front of the log.
All right.
So that immediately becomes that. Now what?
And then you could put the 2 logs that you have to add.
Okay, so what's my next thing?
Sorry, I'm ready.
You can do all 3 of these in one step. Let's do all 3 of those in one step.
Okay, so you have log base 3 4x squared, and then you want to divide that by base 5.
By 5, right. Okay, and that's why my first step is to always move that coefficient up, because then the only thing you have to deal with is the addition and subtraction. I do want to warn you about one thing that's pretty easy to do. What's that equal to?
I don't know.
Trick question. Trick question. Nothing. In other words, it's easy to mistake these rules into doing something like trying to figure out what to do with that. Remember that these expansion and contractions are only when you have multiplication, division, or exponentiation taking place. If you have addition or subtraction inside the argument, there's no expansion to be done. Okay?
Okay. So, I don't know. Can we do SAT first or ACT?
Sure.
Huh?
Yeah, no, I got those. I left off at 32.
Okay.
33.
Alright. So, at what point? Oh, this is standard form, right?
Uh-huh.
So then, oh, I never remember how to do this. Okay. You have to, so,
The y-intercept occurs when x is what?
0. For a second I thought it was talking about the slope, and I was like, I don't know. So then you make x 0 and you just solve?
Uh-huh.
So then 7y is equal to 2 over 7? Or
Yep.
y is equal to 2 over 7?
Yep. The x-intercept means what? If they said, give me the x-intercept of this.
You make y 0.
Uh-huh. That's the thing you got to remember. Is x-intercepts mean y is 0. Y-intercepts mean x is 0. Okay, can you see this number line that they've graphed? Closed,
Yeah.
closed dot there, solid line, open dot there. Which statement shows that?
Y is actually greater than or equal to -4 and J.
Is x less than or equal to -4?
Greater than. No, sorry. So it's going to be G. No, it's going to be F.
F.
Sorry.
That's all right. There's a lot of details here. In other words, this looks almost exactly the same as this. The only difference is the equal sign here, which corresponds to the black dot. So you know how to do this, right, in all situations? I mean, you know how to... Is there a combination of x's that would give you trouble graphing?
Oh.
If I said x is greater than or equal to -3 and less than 18, can you graph that?
Yeah, so then
Okay.
a little, right?
Yeah, so it would just go from -3 to 18, same situation, be solid and open. Open dots are that, solid dots are greater than or equal to. Okay. Geometry, good. We haven't had much geometry. For some reason. Wow, man. Okay. It's a pretty good geometry one, in fact. What's the perimeter of this figure? I'm going to make it just a little bit smaller. There.
Okay, so...
I'm going to draw this. How are we going to do this?
So, you know that the bottom line is 6. I don't know if that helps.
This line down here?
Yeah.
Okay.
And then it's an isosceles triangle?
Okay, because this angle would have to be the same as that angle. Okay, so here, it's not the way I've done it in the past, but this might work just fine. This actually is the best way to do it. This is better than the way I have done it before. I never realized this method.
I'm still trying to figure out. So then you have, this would be the top, and then that's going to be 6 down there.
What's this angle here?
It's going to be 60 again.
What kind of triangle is that?
That's, oh, it's like the angle. No, it's not like that.
Equilateral. Equilateral is 3 equal angles and 3 equal sides. So what are these two side measurements?
It's 6 and 6.
Uh-huh.
And then you have 6.
For 30. Right. Yeah, I had actually done that. I like that method because immediately you find an equilateral triangle. I had actually done it the following way, where I had made a 30, 60, 90 triangle. And I know that a 30, 60, 90, I can figure out that side. In other words, without knowing that's 6. Oh, hold it. Yeah, what I did know, when I did it my way, I knew this was 3. Because I knew this had to bisect that from the drawing. So once you figure out that's 3, you can figure out that that's 6 using similar triangles. But your way was actually a little nicer.
Okay.
Yeah, this is not that easy of a problem. I remember spending quite a bit of time here trying to figure out how I was going to break this thing up and where I was going to draw my lines. Well, partly the reason is that they misdraw the figure. Notice that this point over here is higher up than this point down here, and it shouldn't be. It is not, in reality, higher up. It's the same.
Helpful.
Which does kind of beg the problem that when the way you did it, you connected the bottom and assumed that that line was parallel to this line up here, which it is, but it wouldn't be the way they drew it. In other words, they've kind of intentionally drawn it incorrectly. I guess intentionally.
Okay.
Okay, about this one.
Okay, so, oh goodness.
Obviously, on a problem like this is a back-solving problem, by definition. In other words, you kind of have to go through each statement and see if it's true or not.
Yeah.
So let's start at the beginning. F. What are they looking for? Why are they asking these questions about the signs?
To see if you know how to use a radical?
Well, to make sure you don't take the radical of a negative number.
Yeah.
So if x and y are both negative, does that work? Is that a possible domain? Can x and y both be negative?
Yeah.
Do they have to both be negative?
No.
Okay, so F is half correct. They could be both negative, but they don't have to both be negative, as G immediately tells you, because they can both be positive also. Is J correct or K correct?
No.
So what has to be the answer?
So H?
They either have to both be positive or both negative, which will make that thing positive, and it'll make what's inside the parentheses positive. And that's the only thing they're asking about, is what does it take to make x cubed divided by 2y equal a positive number? All right. Let's see. 93. The ACT test, are there 60 you get 60 questions in 60 minutes?
I believe so. And we have I think we get a minute per question.
Yeah, I think so too. For some reason I was confused lately thinking there's only 36 questions because the score is a maximum of 36. So, but no, that's fine. So for all pairs of real numbers A and S, where A is equal to 2S plus 9, what's S equal to? In case there's any confusion about what they're asking, look at the answers And it's clear that they want you to solve this equation for S.
Yeah. So then the answer would be D?
Uh-huh. Too bad they're not all that easy, huh? Okay. There's our XY plane. There's a line that's perpendicular to the y-axis.
So,
What's the slope of that line right there?
not, wait, it's breaking up again. Oh well, almost. So it would be undefined, right?
No. Vertical is undefined. Horizontal is 0.
Oh, perpendicular. Sorry, there was
Okay.
I think half the battle is just reading the question right.
For sure. I have missed a lot of questions doing these over the years because I didn't pick up the details perfectly of the question, or I misread a keyword. And a lot of those, there was a time where I was recommending students go through and underline keywords. In other words, underline the perpendicular, because that's the most important word in the sentence. I don't do that anymore because it does take time, and I'm not sure whether or not it's worth the time that you have to take to go through and find the keywords and underline them. Probably is worth it, but
yeah, all right. I don't know about doing it on the test itself, but definitely for math.
Hold 1 second, please.
Okay.
Hello? Yes. Yes, hi Peggy. Mm-hmm. Okay. Sure. And that's okay. And Peggy, you caught me in the middle of a session, so I will see you next Tuesday at 9:20. Bye-bye. Apologize. Boy, that'll teach me to answer the phone in a session. Something you heard what happened. I answered the phone and I didn't get a word in for the first 45 seconds. Yeah, here I better go in and. Oh, I can't do it yet. Okay, she was canceling. That's the only reason I answer. Is I'm always afraid it's my next session getting canceling. So, okay. So this is a similar one to one we just did. Let's do this one and wrap it up.
Sorry, I can't see the phone.
You can't see it?
No.
Write down 5y equals 25x minus 50.
Okay, sorry, it's back. I got it. Okay.
Okay.
So then
crosses the x-axis at the point A, comma B.
Okay.
And what is A?
Oh. So it just wants to know the...
Yes. It wants to know the x-intercept. They're just trying to confuse you with all the gobbledygook about A and B.
So you make y 0?
Uh-huh. Mm-hmm.
So x is a 2?
Yep.
So D?
Yep.
Oh, cool.
Okay. And that's a typical question where they really, it was the same question as the other one asking about the y-intercept. It's just that they throw in stuff to try to confuse you and throw you off.
Awesome.
Okay. All right. Well, we're making good progress on this ACT.
Yeah.
When do you take it? April the first
I
time?
take it Not this year. I take it, or maybe, I don't know.
You probably take it in the spring. You're a junior, aren't you?
I'm a sophomore.
Oh, you're a sophomore? Oh, I've been thinking all this time you were a junior.
So,
Wow.
but, yeah, but our teacher was recommending that, especially because I did pretty well on the practice exam,
Uh-huh.
but I struggled with math, so my teacher recommended I start practicing now.
Okay, good. I love it. I don't think there's anything better at teaching a person the math skills they need to know by reviewing the ACT and the SAT. It really gets to the core of the Common Core and dispenses with all the stuff that they teach you when you take a class in algebra or geometry, especially geometry. Geometry's awful. They teach about 4 times as much stuff as you need to really know, instead of just focusing on SAT-type geometry, you know.
Yeah. Well, it's nice to practice. I mean,
Yeah.
it'll definitely benefit me in the future. So.
Yes, it will. In all math, not just for the ACT.
Yeah.
But, okay.
All right, well,
I
can I go
will.
get David?
He's not due until 4:30 unless he wants to
Okay.
start. If he wants to start right now, I'm happy to do that.
I don't know what he's doing. All right.
I'll just wait and call him back at 4:30.
All right.
Okay. All right. Bye-bye.